the molar mass of something is how much 1 mole weighs. And we get those values from the periodic table. So what we want to do on a problem like this is just list out what we have. Carbon, hydrogen, oxygen. Our formula tells us we have 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen. Now I want to multiply that by the molar mass. So I go to my periodic table, and you'll see under carbon, there's a number. We want that number rounded to tenths. That's the mass of a mole of carbon in grams. We'll do the same thing for hydrogen. We look that up, again rounding to tenths. And we do the same thing for oxygen. So I have 12 atoms, or 12 moles times 12. And I do the same thing. I multiply across. And I add those together. I'm going to add down here. So I have 342 grams. This is my molar mass. The mass of 1 mole of this substance has 342 grams per 1 mole. So if I want to do the molar mass of PCl5, I'm going to look up phosphorus, round to tenths, and I only have 1 of those. And then my chlorine, I'm going to look that up, round to tenths, and there's 5 of those. And I'm going to add these two together. And there's my answer. So the molar mass of this guy, I look up uranium, I look up fluorine, let's round it to tenths. Okay, there's 1 uranium and 6 fluorines. So I multiply across. And I add down. I have some potassium. I have 1 potassium. I'm going to look up the molar mass. I'm going to do the same for manganese. Again, rounding to tenths. And the same for oxygen. And I multiply across. And I add down. And there's my answer. This 2 is distributed to this whole thing. These parentheses tell us it's a package deal. PO4 comes together as a group. So if there's 2 PO4s, that means I'm going to double my phosphorus, so there's 2, and I'm going to double my 4 oxygens. 2 times 4, I have 8 oxygens. And I have 1 calcium. The 2 does not go to here because it's not in the parentheses. So I look up calcium on the periodic table. I round to tenths. I look up phosphorus on the periodic table. I round to tenths. I look up oxygen on the periodic table. I round to tenths. I multiply across. I'm going to add these all together, and that's my answer. Anytime I'm doing a conversion, my first step is to write the given. And if you're struggling with these, go back to section 3.3. Make sure you know how to do the process. I want to write my given. Step number 2, I want to multiply it by some fraction. Step number 3, whatever is up here, unit-wise, I put down here. I don't carry the numbers over, just the units. So I'm in molecules of water. The question says how many moles. So what I'm trying to change it to goes on top. And then we have a ratio that we should have memorized, and that is 1 mole, it's always 1 mole, is Avogadro's number of molecules. That's a constant. This is something to memorize. I cross off my like units. That leaves me with units of moles. Now if I take my numbers and my exponents, I can subtract because I have 1 on top, 1 on the bottom. I'm dividing them. So 24 minus 23 is 1. I'd plug that in my calculator, and that's my answer. Here I'm looking for how many atoms of zinc. I'm going to write my given, my starting point. Whatever's up here, I put down here, not the numbers, just the units. And on top goes what I'm trying to get to change to. I'm trying to change to atoms. Well, zinc, if I have 1 zinc, I have 1 atom. So I can put atoms up here. Now my ratio of atoms to moles is 1 mole is a lot of atoms. And that's a constant, this ratio. Cross off my like units. I'm left with atoms. Multiply that, and that's my answer. The mass of 1 mole of oxygen. Well, there's 2 ways we could do this. That's my given, 1 mole of oxygen. I'm going to put my units down there to cancel. It's asking for mass. Mass is grams. And then my molar mass, I go to my periodic table. I look up oxygen. There's 2 of them. My periodic table tells me oxygen has a mass of 16. And so it's 32 grams. It's always 1 mole for mass to moles. And I cross that off. And again, you could skip this whole conversion here and just add them up, because this is, after all, molar mass. The molar mass of this, I have 6 carbons, I have 12 hydrogens, I have 6 oxygens. I go to my periodic table, I look up carbon. It tells me it's 12 grams for each one. My hydrogen is 1 gram, and my oxygen is 16 grams. And I multiply across. And I add vertically. And that's my answer. The molar mass of this substance is 180 grams per mole. I have 1 sodium atom. I have 1 hydrogen atom. I have 1 carbon atom. and I have 3 oxygen atoms. I look up the molar mass on the periodic table. Underneath sodium, it tells me it has a mass of 23. I round that to tenths. Hydrogen is 1, carbon is 12, and oxygen is 16. I multiply across. I add them vertically. I have 7 carbons. I have 12 hydrogens. Look up carbon on the periodic table. It's 12. I look up hydrogen on the periodic table. It's 1. I multiply across. And I add vertically. So this is a conversion problem. I'm going to start by writing the given. Now I don't want the given, so I'm going to write it down here so I can cancel it out. On the top, I want to put what I'm trying to change to. So the question says mass in grams, so I'm going to put grams on top. I'm going to go to my periodic table. I'm going to look up my lead, and I'm going to look up my oxygen. I only have 1 of each. The number underneath lead and the number underneath oxygen, and so I just add those together. That's my number of grams, and that's how many is in 1 mole. And I just multiply across.